All right, video lesson 11.6, dividing a line segment proportionally. So we've done this from a construction perspective. We've had multiple ways where we can take a line segment, we can divide it into equal portions. But now we want to be able to do it in an algebraic or coordinate method. So let's use the graph right now just to kind of visualize what's going on, but we're going to be able to do these without having to use a graph or a compass or anything like that. So let's take the opportunity though to kind of look at this one. So let's graph these points. Let's see, so I've got -2, 0, which will be right there, and we've got 5, 8, which will put me right here. Just for argument's sake, let's call this A and B for notes here. So this is point A, this is point B. I'm just going to connect those two things. So there we go. So the question is saying here, it divides this line segment into a ratio of 1 to 3. So I want to find a point that breaks this up into, so that I have one piece on the left side and 3 pieces on the right side. So just to kind of mentally vision that right now, right? I've got here, I want to find a point so that this is one section, and that I've got 3 equal sections over here, right? So if that's the case, right, if I got 1 here, and I've got 1, 2, 3 over here, the part that usually messes everybody up is how many sections is this total, right? That means there's a total of 4 segments, right? So even though the ratio is 1 to 3, that's a total of 4 segments, right? So that's key. That's going to be important for us to work here. So let's start off by doing this. Now, I like to do this in like a 3-step process. There's a formula. You could go out, and if you look at other videos, you could find a formula and just kind of, utilize the formula. I'm not a really big fan of the formula. I'd rather just kind of go through this systematically. I think it's a little bit easier if you just kind of remember these 3 simple steps. And then kind of just, practice those steps. I find it to be a lot easier in the long run than having to worry about the formula, because the formula is a little complex. And kind of, confuses a lot of people. So step number 1, all right, I want to find the overall slope. So I'm looking for the slope of AB in this case, right? So what is that going to be? So that's going to be 8 minus 0 over 5 minus -2. So that gets me 8 over 7. All right. Now, even if I could simplify that, I do not want to. All right. From there. So, step number 2. Let's see here. So, step 2 is I want to find the change. I want to find how much it's being changed proportionally. So, what we do is we're going to take what I refer to as like the delta x and the delta y. Right. That's up here. So, this is delta y. This is delta x, right, and in my slope. So I want to take that change. So I want to figure out here. So in this scenario, we're going from A. So unless they tell me otherwise, always go with the leftmost point, unless they specifically say it's coming from the other direction or something. But take the leftmost point. So I want to go from here, and I want to say, what proportional change could I occur? Right now, we've got this, right? We've got all the way up here and all the way this way. So I want to basically say, how can I divide this up into 4 segments? So that would be like 1, 2, 3, 4 equal segments, right? And how could I divide this one up here into 4 equal segments? And where do those things intersect? Now, obviously, this is a change of 7. So 4 is not exactly a nice division there. It's not a whole number division. So again, that's why having the graph itself is really not necessary or important. It's really a matter of being able to do it algebraically. So I'm going to take each of these numbers. So again, I always like to start with the x because our coordinates start with x. So I'm going to take the 7, and I'm going to multiply it by whatever this segment was. So in this, even though it's a ratio of 1 to 3, that means I'm going to have a fraction of 1 out of 4. All right, so I just simply add up whatever the ratio is, and it goes, the first number goes on the top, and then the total goes on the bottom. So I'm going to multiply this by 1/4. I'm going to do the same thing for my delta x here. I'm sorry, delta y's here. So I'm looking for, in this case, that was 8, right? And I want to multiply that by 1/4 also to find out what my change is going to be. So when I multiply that, I get 7/4, which in that case is 1.75. And I want to find out what 1/4 of 8 is. That's just going to be 2. So for my third and final step here, step number 3, we want to take these changes. So I want to take these two values that we just found, and I'm going to add them to the point. In this case, I said we were going from A. So I'm going to add them to A to tell me how much change. So I want to know how much vertical change, that's my Y. How much horizontal change, right? That's going to be my X. So starting with that point, so the first point, so point A was -2, 0. And I'm going to, like I said, we're going to add the 1.75 to my X's, and we're going to add the 2 to my Y's. And that's going to get us a point of, what is this? That would be -1/4 or -0.25. And this would be 2. All right, so for argument's sake, I'm just going to call this W. All right, so let's say point W here. So again, in my change here, up 2 over 1.75, that's this point right here. That would have been my W. That's the one that happens. Now, if I kept doing that, right, I would get 3 more equal sections over here. Right, I have 1 on this side. I'd have 3 more on this side. So that's the point. This is the point that directly divides that line segment into a ratio of 1 to 3. Right? This is also referred to as directed line segment, meaning what point directly divides the line into the ratio that you are talking about. All right, let's do that again, because like I said, this is definitely something that's new and a different thought process. So let's take the opportunity to try that again. So let's look at example number 2. All right, so like I said, so the first thing is, let's do step 1, right? Find the overall slope. And again, something you're not going to hear me say very often, but don't simplify. All right, don't simplify that. All right, so what's that first step going to be? Let's see. So the slope is going to be, we got 8 minus -2 over 4 minus -3. So that's 10 over 7. So I couldn't simplify it, but even if you could, don't. All right, so step 2. All right, we're going to multiply our slope. Actually, let me say that. We're going to multiply our delta x and our delta y, because I want to multiply each individual one, by the fraction. And the fraction represents here what portion of that. So in this case here, again, we want 3 out of a total of 5. So in this case, we're going to multiply a fraction of 3/5. All right, so for step 2 here, so my delta x, all right, that's my bottom. So that's going to be 7 times the 3/5, which equals 21/5. And that one is, what is that, 4.2. And my delta y, that's my top number, so it's 10 times 3/5. And that's a nicer one, that just comes out to be 6. So now for my last step, so for step 3, we're going to add the x and y change, which is what we just found. So that's these two things here, right? To the coordinate. And again, we're always going to use the leftmost coordinate. So in this case, that would be this one here. So for here, I'm just going to do this up here. So we're going to take -3 comma -2. And we're going to add these two values. So I'm going to add the 4.2 and I'm going to add the 6. Again, just make sure you're adding it. This was my x change, so I want to add it to the x. This was my y change, I want to add it to the y. All right, so that's going to give us a final answer of here. What do we get? That's 1.2, and this is 4, and we'll call it point P for this one here. So point P, don't forget your parentheses because it is a coordinate. So I'm just going to arbitrarily call this point P. So the point that divides this segment into a ratio of 3 to 2 is 1.2 comma 4. All right, so that's your directed line segment process. So again, 3 steps, right? Find the slope, don't simplify it. Take each number in the slope, multiply it by whatever fractional amount you are dividing, and then take those answers and add them to the point, the leftmost point, or whichever point you're coming from. Obviously, if I was going from the other side, I would be subtracting it away, from there. But again, so just think of it as the simplest way of just saying always take the leftmost point and add it in, unless you have no other choice, unless they tell you to do something else. All right, one more example. Again, like I said, this is one of those things, the more practice you do with it, the better it will be overall. So step 1, find your slope. So slope of FG equals, that's going to be 6 minus 2, 2 minus 0. So I got 4 over 2. Again, do not simplify. All right. Then I'm going to take my change. So my delta x and my delta y. So in this case, I'm taking the 2 and the 4. And I've got to multiply them by the fractional change. So in this case, it says if point S lies 5/12 of the way along. They gave me the fraction, right? They've given me that it's 5/12 of the way. So that's my fraction. I don't have to make it into a fraction for that one. So if it was a ratio, just to kind of think back, right? This would have been 5 to 7, right? Because I take, again, the first number and then I add the 2 for to make the denominator. So if it was a ratio, it would have been a ratio of 5 to 7, which would have given me the 5/12. But I didn't have to do it. It was less work. All right, so with that being said, I get an answer of here. What do we get here? 5/6. And this one here ends up being 5/3. All right. And so now I'm going to take these amounts and I'm going to add them to the leftmost point. So in this case, F. So F is currently 0, 2. I'm going to add 5/6, and I'm going to add 5/3 to the x and y respectively. And this one comes out to be, and this is point S. So S ends up being 5/6, and 2 plus 5/3. Not a nice number, not a decimal, so that'd be 11/3. All right, so you can plug that in the calculator, or as I just did in my head, I took 2, made it have a common denominator of 3, so it'd be 6/3, and then added them together from that one. But that would be my point. So this is now your point that specifically divides the line segment so that it is 5/12 of the way. So again, if you were to kind of like visualize this, you have a line segment here of F to G, right? This point is 5/12 of the way, so that's a little bit less than half. Like, right, this would be half, so it would be something right around here, right? And it would mean here that you'd have 5 pieces on this side, and you'd have your 7 equal pieces on that side. All right, that's what that represents. So that value, that's the actual coordinate that it would be for that 5/12 of a way. All right, so that's directed line segment. Again, I personally just like this like 3-step method. I think it's a little bit simpler in the grand scheme of it. It is maybe a little longer than using the formula, but I think it's a little bit more straightforward. So take an opportunity, review the video and take the notes and try to make sure you understand everything, and then utilize the practice problems as for better understanding.